Probability of an event occurring is given by all the ways in which that event can occur divided by all possible events. Now, probability of any event is always between 0 and 1, both inclusive. So, probability of 1 would mean that there is 100% chance that the event will occur, and similarly, probability of 0 would mean that there is no chance that event will occur. One thing to note here is that you must ensure that the numerator is a subset of the denominator. So, meaning, let's say uh, the events are 1, 2, 3, 4, 5, or 6. Let's say these are all the possible events. Let's say this is the denominator. So the numerator must be out of this 6 events, right? So it could be 1, 2, 3, anything, up till 6, like uh, any number of events up till 6. But it cannot be 1, 2, 3, and 7, right? Because 7 is not part of the denominator, right? So even 7 is missing from the denominator, so this is not fine. So the numerator must be contained in the denominator. Now, let's solve some examples to see how we can use this formula. So let's say there are 5 red balls and 3 green balls. If one ball is picked at random, what is the probability of picking a red ball? All possible events is 8, right? So first thing we need to do is find the denominator. So the denominator is 8, right? We're picking any one ball out of 8 given balls. Now the number of desired outcomes is basically what the question is looking for. The question is looking for a red ball, right? Now any one of the 5 red balls is fine, right? So the number of desired outcomes is 5. So probability is 5 divided by 8 of picking a red ball. Now take another example. Say there are 5 red balls and 3 green balls. If 2 balls are picked at random, what is the probability of picking 1 red ball and 1 green ball? Now notice that the order in which the balls are picked does not matter, right? The question is not saying that first pick a red ball and then a green ball or vice versa, right? So in this case, we can solve this question in 2 ways. So the first method is finding all possible events of picking 2 balls. Basically, in this first method, we find the denominator, the total number of outcomes. Now, all we are doing is all possible events would mean there are 8 balls and we're picking any 2 out of them. So what we are looking for is unique combinations of 2 balls out of 8 balls. So that's basically 8C2, which comes out to be 28. So that's your denominator. Now, out of this 28 unique combinations, we need to find how many of them contain 1 red ball and 1 green ball. That's your number of desired outcomes. So in this case, it is 5C1 times 3C1. That is the number of unique combinations which contain 1 red ball and 1 green ball. So that is 15. So the probability of picking 1 red ball and 1 green ball is 15 divided by 28. Now, the other way of solving this is assuming the order in which the balls are picked. So in this case, what we do is we find the probability of one ball at a time. So let's assume the order is first red ball is picked, followed by a green ball. Now, probability of picking a red ball is 5 by 8, right? This is what we saw in the previous question. Now, since one ball is already picked, what is the probability of picking a green ball? So notice that the denominator is no longer 8, it's 7, because we already picked one ball. So the second ball that is picked, what is the probability that it is a green ball? So the all possible events is 7 now, right? We have 7 balls to pick from, and any one of the 3 balls, any one of the 3 green balls is fine. So that is the number of desired outcomes. So that's 3 by 7. So the probability of picking a red ball followed by a green ball is 5 by 8 times 3 by 7. Now, since the question does not mention the order, we also need to account for the other order, right? So that is green ball picked followed by a red ball. Now the probability of picking a green ball followed by a red ball is 3 by 8 times 5 by 7. So 3 by 8 is the probability of picking a green ball, right? So there are 8 balls, any one of the 3 green balls is fine. So that's your probability of picking a green ball. Now the second ball picked has to be red. So again, notice that the total number of outcomes is 7 now, out of which 5 of them are red balls. So the probability of picking a red ball uh, on the second attempt is 5 by 7. Now we need to add these two probabilities to find the overall probability of picking a red ball and a green ball. And notice that both these probabilities are the same. So we just multiply uh, the probability of this by 2. So it's 2 times 5 by 8 times 3 by 7, which is 15 by 28. Notice that this is exactly the same as uh, this number here.